All right, these are the solutions to the final exam that you took on Wednesday. If you're taking the AP test on the 22nd, I hope you're going to watch this video and fill some gaps, because every question on this exam is, I wouldn't be surprised if some part of it fell on the AP test. All right, so 42% of the people shop at Target, 27% shop at Aldi, 11% shop at both. So a great way to analyze this situation is with a Venn diagram. And so another way would be a two-way table. And so they tell me that 11% of the shoppers spend their time at Target and Aldi. And so what that means is if I take the 42% minus the 11%, I've got 31 people, 31%, who only shop at Target. And then the 27 minus the 16, 27 minus 11 is the 16%. So 16 only shop at Aldi. And then outside is the people who don't shop anywhere. So 1 minus all of that is 42%. So the 42% I'm getting from taking 1 minus 31, 11, and 16. And so with this Venn diagram, I can answer all of these questions. What is the probability that a person shops at Aldi or Target? You're looking at the 31 plus the 27, but then we will subtract the overlap of 11%. Correction, that should be the 42%. So and I find that 58% shop at Target or Aldi, and that's confirmed by the 58%, 31 plus 11 plus 16. The chances that a person does not shop at either store, that's the 42%. Right? These are complements of one another. We either shop at Target or Aldi, or we shop at neither. So these two add up to 1. And then to do the simulation, let me just show you how that would work. So with the simulation, we want to use a random digit table, or preferably I would choose a graphing calculator, a random number generator. So if I go to, let's see, it'd be math, probability, and then if I go to a random integer, so 1 through 100, and I would have to designate 1 through 42 would represent I am not a shopper at either store. And then since we have 5 people, I'm going to get 5 random numbers. And then let's see. So this is a simulation. Notice that one number being less than 42 would imply this is a trial where 1 does not shop at either store. So if I press enter, this is a trial where 2 do not shop at either store. And so let's see how far we have to go until nobody shops at either store. No, it might take a while. What I'm looking for is a trial where no number is less than 42. And so you can see this probability is going to be pretty low, because even after about 12 trials, I have yet to find a sample that doesn't have a 42. But that gives you the idea, right? So you'd have to describe that process in terms of how to run a simulation. All right, suppose you randomly choose 10 people. What's the chances that exactly 3 of them are at Target? So this is what we call a binomial setting. Okay, so this is where we have to use that combination. So 10 choose 3. This is a number of ways you can put 3 people in a group of 10, and 3 of which are shoppers at Target, and 7 of which are not shoppers. If you remember, an easy way to find that calculation was distribution, and this would be a binomial PDF, and the number of trials was 10. The chance of success was 42, and with 3 trials, the chance of finding 3 out of 10 is about 20%. Alright, so given that a randomly person selected shops at Target, what's the chance that the person shops at Aldi? So this is a very popular formula. What's the chances of A given T is the same as the chances of all the shoppers divided by the probability of Target shoppers. So 42% of the people shop at Target. How many of those 42% shop at Aldi as well? That's the 11%. So 11 over the 42 is going to be this probability. So that was about 26%. All right, consider a sample size of 50. Describe the sampling distribution. These are important. This is what your confidence interval and your significance test are built upon. So if the true proportion of people that shop at Target is 42%, and I go out and get a sample of 50 people, I might get a sample whose proportion is less than 42%. I might get a sample whose proportion is greater than 42% or exactly 42%. With sampling variability, you're going to get a wide range of proportions, and we talked about how the distribution of this is going to be somewhat normal if a condition is satisfied. So when we talk about describing a distribution, we need the center, which in this case the average is going to be the average of that's going to be the proportion of the population. The spread is the standard deviation, which is the 42% times the 58% all over the sample size square rooted. And then we need to talk about, is this normal? Yes, it is. It's normal because the NP is greater than 10, which in this case is the 17. Or, excuse me, and that's on the next one, but in this case it's going to be 50 is the sample size, and P is 42%. So that there is more than 10, so is the complement. So when they talk about describe this distribution, the center is 42%, the spread is this standard deviation, and the shape is going to be approximately normal. Okay, you did really well here. The explanatory and response, so they're running observational study. The explanatory is simply whether or not there's a stay-at-home order, and the response is the percentage of Target shoppers. This is an observational study, and to be specific here, they do not apply a treatment, so this is an observational study. Okay, so then we have the conditions are those conditions that I just described with the sampling distribution. In addition to random, you have to have a random sample, which they describe in the prompt. You have to have a normal distribution. So in this case, we would use the p hat. So n times p hat and n times 1 minus p hat. Those are both more than 10. And exactly this is 17 and this is 33. So it's good to show those counts. And then with your independence, we have to make sure that our sample size is less than 1/10 of the population. So 1/10 of 500 is the sample size here. So we would say something about, we would assume that there's more than 500 Target shoppers. Okay, so we run our confidence interval and they go ahead and calculate it for us. So question A is something we need to talk about. So a lot of us put the confidence interval. So if it had said confidence interval, you would be right to say we are 95% confident that the true proportion of Target shoppers is at 42%. Okay? Let me try that again. If it said confidence interval, we are 95% confident that the true proportion of Target shoppers is from 21% to 47%. Now, since this says level, they're wanting you to talk about what it means. So we would say something like, if we were to construct many different confidence intervals, then 95% of those would capture the true proportion of Target shoppers. So it's a subtle yet important difference when they're talking about level and interval. And so based on the confidence interval, is there convincing evidence? The answer is no. Since this interval has 42% inside its interval, then 42% is a plausible proportion of shoppers as prescribed by our confidence interval. Now, if we had a confidence interval that was that did not contain 42%, then we would have significance evidence to show that it is different. Okay, I'm going to try that again. I'm not sure what got recorded, but I'm going to repeat myself maybe. So to interpret the confidence level means that we would say if we were to repeat this sample and find many different confidence intervals, then 95% of those intervals would capture the true proportion of Target shoppers. And so based on the confidence interval, is there convincing evidence? The answer is no. Since 42% is in this interval, it's a plausible percentage of shoppers for the true percentage of shoppers. If our interval did not have the 42%, then we would have evidence to show that the proportion of shoppers is not 42. Okay, so then we're going to move on to our second half of this, where it starts to talk about a significance test. Wait time means the amount of time customer stands in line waiting for a checkout. Assume that distribution of all wait times at all target customers. So that's the population. So they tell you the population has an average of 4 with a standard deviation of 1.5. We're going to go out and think about a sampling distribution. So with a sampling distribution, I go out and get 40 random shoppers and get the average wait time. So let's call it X bar. I'll go out and get another sample and call that X bar. So each of these X bars represents the average shopping time for random sample of 40 people. What you're going to find is that these X bars are going to be centered around 4 minutes, because that's the population's average, but your variation is going to be decreased, right? So we would call this mu of X bar. The spread of this is going to be the population standard deviation over the square root of the sample size, which is about 0.24. And so just by thinking about what that means is, 3.5 minutes is going to be 2 standard deviations away, and 4.5 minutes is going to be to the right. And so this is a description of your sampling distribution. Would it be the SOX, right? The shape is normal, approximately. There's no outliers, right? If you say normal distribution, we're implying there's no outliers. The center, we would say, is going to be 4 minutes, and excuse me, the spread is going to be 0.24 minutes. Okay, so with the sampling distribution, we're going to construct and run a test of significance. So mu is going to be your average wait time, and you have to be specific here, at the local store. So we're making an inference on the wait time at this particular store. So our null hypothesis is that this average wait time is equal to the average wait time of the nation, which is 4 minutes. And then alternative is we think it's going to be less than 4 minutes. So this is a one-sided test of significance. So our question now is, if the wait times at our local store are no different than the wait times nationally, then what's the probability that she will get an average of 3.5 minutes or less? I hope that you recognize this is the p-value. The p-value is the chances that we get a statistic this far from the average or less. Well, it's all about the sampling distribution, right? So our X bar is about right there, and we want to use that X bar to find a z-score. So if I take our 3.5, this is our average, this is our observation, minus the average of our distribution over the standard deviation, I'm about 2 standard deviations to the left. So then to find this probability, I can use a z-table, or I can use the distribution, a normal CDF. And so with a normal CDF, I'm going to go all the way to negative 2.08. And then if I paste that in, this will give me the probability, which is about less than 2%. So your p-value is 0.018 approximately. So we go ahead and say on this next question that our p-value is less than 2%. So this is evidence to reject the null. And so they want you to explain a type 1 error in the setting. So we're really good at saying the following. We're really good at saying a type 1 error is when we reject the null if it's true. But what we're not good at is writing it in context. So what you would have to say is, on top of that, is to put it in context of our study, of our experiment. And so the idea is the H naught is true. So it is true that our average shopping time, our average wait time, is the same as the national, but we think that is different. So put it in context whenever we talk about those type 1 errors. All right, so finally we're getting to our two variable data. Identify, interpret, and context the slope and the y-intercept. So this right here is our slope. I'll use b or y-intercept, and this right here is our slope. So what I could do is I can write y hat as our least squares regression line is 174.4 times x plus the 72.95. So with this I can try to interpret what that means. So the slope says that if I increase a customer in line by 1, then the time will increase by 174 seconds, right? So slope is over 1. This is change of time over change in customers. So if I increase the customer in line by 1, I would expect that the wait time to increase 174 seconds. So your y-intercept is just if you have 0 people in line, you would expect a wait time of 72 seconds, which that's a great example of extrapolation, right? If there's no people in line, you would expect a wait time of 0. And so for the final question, this number is the square of our correlation coefficient. So if I take the square root of 0.733, I get 85%. So this right here, R, has a value. So my correlation coefficient is 0.86. So you need to reference that. So this comment on the strength of the linear relationship. To get all points here, you would say the correlation coefficient is 0.856, which would indicate a strong relationship between customers in line and the wait time. Okay, so if you just said there's a strong relationship, they're going to want you to, how do you know that? Well, we're going to reference the correlation coefficient. And so the outlier, so what we're going to do is we're going to use that y hat. So here's the y hat again. Okay, so our least squares regression line is the y hat, is right there. So if I use it to predict the wait time for 3 customers in line, I get 596 seconds. So this is my predicted wait time for 3 customers in line. And so a residual is the actual minus the predicted. Well, the actual is 70, and then the predicted is the 596.15. So my residual is about negative 526 seconds. All right. I hope that's helped. I'll see you on Friday at 10:15.